Welcome all of you to the chemistry online classes. So today's class we are going to discuss about the shapes of the atomic orbital and quantum numbers. So as you know, atomic orbitals that may be a S orbital, P orbital, D orbital, F orbital. Okay, the shapes of those orbitals that we need to know. See here, this is the S orbital which is having which is spherical in shape. S orbital is spherical in shape, and as you know there are 1s, 2s, 3s, 4s and so on. S orbitals will be there, and the energy of this 2s is greater than 1s, and that is greater than that of 2s. 3s is greater than 2s, and 4s is greater than 3s. So energy is in the increasing order, these orbitals, and all these S orbitals, that atomic orbitals, are spherical in shape, and when these are oriented along the XYZ axis, the shape of the S orbital will be spherical. And many times draw the structure of the S orbitals. For 1 mark in your examination the question is asked. Just you have to draw like this, and you have to mention that the S orbital shape is spherical. Or sometimes what is the shape of the S orbital, the question will be asked in such a way also. During that time your answer must be S orbital, or the shape of the S orbital is spherical. Clear? So let us go for the P orbital. As you know, P orbital further consisting of the 3 subcells, that is Px, Py, Pz. Here the P orbital is having the dumbbell shape. P orbital is having the dumbbell shape, and this P axis, it means the P orbital, it is situated along the x axis, that is why it is a Px. If it is situated along the y axis, it will be a Py. If it is situated along the x axis, z axis, then it will be a Pz orbital. So like this we are dividing the P orbital into Px, Py, Pz. Only the difference is that those are oriented along the x, y, z axis. That's it. If it is along the x axis, that is Px. If it is along the y axis, that will be a Py. If it is along the z, means that will be a Pz. And all these 3 are having the dumbbell shape. All these 3 are having the dumbbell shape. Dumbbell, you know it. In the same way our P orbital is present. And then D orbital. D orbital is having the double dumbbell shape. It is having the double dumbbell shape like this, double dumbbell. Okay, and then there are 5 suborbitals in the D orbital, that is dxy, dyz, dzx, dx square minus y square and dz square. See here, dxy, dyz, dzx. Here the lobes of the orbitals, these are the lobes. The lobes of the orbitals are present in between the, if it is dxy, if it is dxy, these 2 dumbbell shape, that is a double dumbbell shape of these x and y, these are situated. The lobes of the d orbitals are situated or present in between the x and y axis. In between the x and y axis, like this, in between the x and y axis, if those are situated, that will be a dxy. If these lobes of the orbitals are situated in between y and z axis, means that is a dyz. If it is in between z and x axis, then it will be a dzx orbital. If it is along the x and y axis, it will be, in case of the dx square minus y square, it is along the axis. It is means the lobes of the orbitals, whatever these lobes of the orbitals are, if it is along, in case of the dx square minus y square, and in case of the dz square, it is a single dumbbell which is situated along the axis like this. It is the structure of the dz square. So simple, there are 5 d orbitals, all are having, it means except dz square, all are having the double dumbbell shape, and these, in case of these 3 dxy, dyz, dzx, these are, the lobes are present in between the axis, while in case of these 2, those are along the axis. So I am giving you homework as draw the structure of the all d orbitals. Draw the structure of the all d orbitals, and I have shown you S and P orbital, and one more orbital is there, that is F orbital. The shape of the F orbital is said to be a complex. The shape of the S orbital is said to be a complex. It means it is highly complex, and it consisting of the further 7 subdivisions, like D is having 5. Similarly, F orbital is having the 7 sublevels we can able to say, and the shape of that F orbital is complex. I hope so it is clear. So, how many atomic orbitals are there? S, P, D, F, and the atomic orbital which is S, it is having the shape spherical, it is spherical in shape, and the P orbital is having the dumbbell shape, and the D orbital is having the double dumbbell shape, and then F orbital is complex. Clear? And then the P orbital is further categorized into Px, Py, Pz, and then D orbital is further categorized into dxy, dyz, dzx, dx square minus y square and dz square, and F is similarly categorized into 7 sublevels, and the shape of that F orbital is said to be a complex. I hope so it is clear. Simply just you remember what is the shape, and sometimes they might be ask you draw the structure, and I am giving you homework for the drawing the structures of the D orbital. Drawing the structures of the D orbital, 5 different structures you have to draw. Clear? I hope so this part is clear for you people. So, let us move towards one more very important bit of the topic, and the question will be asked on this. Many times the question is asked on this concept only. So, let us discuss about that concept. The concept name is nothing but quantum numbers. So, what are quantum numbers? See here, the quantum numbers are the set of numbers which gives the complete description about an electron. A set of numbers which gives the complete detail or description or details or information you can take. Okay. A set of numbers. What are quantum numbers? Sometimes the question will be asked. So, what are quantum numbers? A set of quantum numbers, a set of numbers you can say, a set of numbers which gives the complete description about an electron, or which gives the complete information regarding the structure of an electron and regarding some other details regarding an electron. Such a set of numbers are called as quantum numbers, and there are mainly 4 quantum numbers. Okay. Principal quantum number, Azimuthal quantum number, magnetic quantum number, spin quantum number. Are you getting my point? So, what are quantum numbers? A set of numbers which gives the complete description of an electron are said to be quantum numbers, and there are 4 types of the quantum number: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. So, let us discuss what these exactly gives information regarding an electron. So, let us go for the first one, that is principal quantum number. So, the principal quantum number mainly represent the main energy level. It represents main energy level, and this is represented by the N. It is represented by a letter N. As you know, this is the nucleus. This is the nucleus, positively charged nucleus, and the surrounding orbitals. These are the orbitals which are present around the nucleus, and here we are representing n is equals to 1, n is equals to 2. These n is nothing but principal quantum number. It represents the main energy level. It represents the main energy level of an electron, and even it describes regarding the total energy. Total energy of electron, and even it gives the idea about the size of the orbital. Even it gives the idea about the size of the orbital, and As the value of the n increases, it will be a higher energy level. If n is equal to 1, it is lower energy level. So, as the value of the n is increasing, it is the higher energy level. Just you think in between these two, this is having the lower energy level, this is the higher energy level. It means the value of n is increasing. So, as the depending upon the value of n, if value of n is increasing means, if it is increasing means the energy level also increases. Energy level increases. Are you getting my point? As the value of n increases, the energy level also increases, or the energy level, we are going to say this is the lower energy level, this is the higher energy level. Suppose if I draw one more, n is equals to 3, now it is higher energy level. Now it is higher energy level. So, as the value of the n increasing, the higher energy levels are occurring. So, if n is equals to 1, that is what we are going to say, it is K cell. If n is equals to 2, L shell. If n is equals to 3, M shell. If n is equals to 4, that is N shell. Yes or no? So, like this we can tell regarding the principal quantum number. The principal quantum number is represented by the letter n, and it represents the main energy level, and then it describes, it gives the idea about the total energy of an electron and size of the orbital. So, as the value of the n increasing, it is said to be a higher energy level. Clear? So, now let us go for the one more quantum number, that is Azimuthal quantum number. So, here the Azimuthal quantum number is represented by the letter small l. It is also called as subsidiary quantum number. It is also called as angular momentum quantum number. All these are the alternative terms for the Azimuthal quantum number. I hope that is clear. So, what is Azimuthal quantum number is represented by the L, and this represents subcell. The Azimuthal quantum number represents the subcell, whether it is S orbital, P orbital, D orbital, whatever, that it will represented by the Azimuthal quantum number, and even it determines the shape of the orbital. Even it determines the shape of the orbital. So, first of all, the Azimuthal quantum number represents the subcell, and it gives the idea about the shapes of the orbital. It gives the idea about the shapes of the orbital, and then the value of the L depends upon the value of the M. Okay. And then that is, I am going to write, suppose the value of n is equals to 1, n should not be 0, n represents the energy level. Always the first energy level is represented by 1, always the first energy level is represented by 1. So, if n is equals to 1, then L is equal to 0. It is having only one subcell. It is having only one subcell. Suppose n is equals to 2, then the value of the L is 2 numbers. It means 0 and 1. 0 and 1. If n is equal to 3, just you think, L is equals to 0, 1, 2, 3 numbers. If n is equals to 4, L is equals to 0, 1, 2, 3. Are you getting? If n is equals to 1, always the value of the L is 0. It is having only one subcell. If n is equals to 2, L is having the two values 0 and 1. It means it has two subcells. It has two subcells. If n is equals to 3, L is having the 3 subcells. If n is equals to 4, L is having the 4 subcells. Are you getting my point? N is 1 means L is 0. If n is 2 means L is 0 and 1, 2 values. If n is 3, L is having the 3 values, that is 0, 1, 2. Clear? So, here one more thing I want to tell you, on the basis of the value of the L, the names of the subcells are given. So, L value ಮೇಲೆ ಯಾವ subcell ಅಂತ ಹೇಳಿ ನಾವು ಹೇಳ್ತೀವಿ. So, ಇಲ್ಲಿ ನೋಡ್ರಿ, these are the value of the L. So, L value ಇಲ್ಲಿ ಬರೀತೀನಿ ರೀ 0, 1, 2, 3, 4. ಅದಕ್ಕೆ ಯಾವ ಸಬ್ಸೆಲ್ ಅಂತ ಕರಿತೀವಪ್ಪ, L 0 ಇತ್ತಂದ್ರೆ ಅದು S ಸಬ್ಸೆಲ್. L ವ್ಯಾಲ್ಯೂ 0 ಇತ್ತಂದ್ರೆ ಯಾವ ಸಬ್ಸೆಲ್ ರೀ, S ಸಬ್ಸೆಲ್. L ವ್ಯಾಲ್ಯೂ 1 ಇತ್ತಂದ್ರೆ P ಸಬ್ಸೆಲ್. L ವ್ಯಾಲ್ಯೂ 2 ಇತ್ತಂದ್ರೆ D ಸಬ್ಸೆಲ್. If it is increasing, you can go S, P, D, F, G like that. If L is 0, that subcell is always S. If L is 1, that subcell is always P. If L is 2, that subcell is always D. If L is 3, that subcell is always F. Keep in mind. If it is clear means, then only you can able to understand next two quantum numbers. Okay. So, if on the basis of the value of the L, we are going to write regarding the which subcell it is, whether it is S, P, D, F, and the total angular momentum of an electron. Angular, this is 1 point, and angular momentum of an electron is calculated by formula L is equal to square root of L into L plus 1 into bracket H upon 2 pi, where L is the Azimuthal quantum number. Are you getting? So, ಏನಲ್ಲಪ್ಪ, n ವ್ಯಾಲ್ಯೂ ಮೇಲೆ L ವ್ಯಾಲ್ಯೂ ಡಿಪೆಂಡ್ ಇರ್ತೈತಿ. ಸೊ, ಕಂಪಲ್ಸರಿ ನೀವು ಇದನ್ನು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಬೇಕ್ರಿ. n ವ್ಯಾಲ್ಯೂ ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಕೈತಿ, 1, 2, 3, 4, 0ದಿಂದ ಆಗೋದಿಲ್ಲ. ಯಾಕಂದ್ರೆ ಎನರ್ಜಿ ಲೆವೆಲ್ ನಾವು ಅಲ್ಲದಾವ್ರಿ, ಪ್ರೆಸೆಂಟ್ ಐತೆ ಅದು 1 ಹಿಡ್ಕೊಂಡ್ರೆ ನಂಬರಿಂಗ್ ಕೊಡ್ತೀವಿ ಇಂಟೀಜರ್ಸ್. ಓಕೆ. ಸೊ, n ವ್ಯಾಲ್ಯೂ ಮೇಲೆ L ವ್ಯಾಲ್ಯೂ ಡಿಪೆಂಡ್ ಇರ್ತೈತಿ. L ಅಂದ್ರೆ ಏನ್ರಿ, ಅಜುಮ್ತಾಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್. ಏನು ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೈತಿ, ಶೇಪ್ಸ್ ಆಫ್ ದಿ ದಟ್ ಇಸ್ ಸಬ್ಸೆಲ್ ಅನ್ನು ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೈತಿ, ಶೇಪ್ ಆಫ್ ದಿ ಆರ್ಬಿಟಲ್ ಅನ್ನು ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೈತಿ. ಓಕೆ. n ವ್ಯಾಲ್ಯೂ ಮೇಲೆ L ವ್ಯಾಲ್ಯೂವನ್ನು ಅಸೈನ್ ಮಾಡ್ತೀವಿ. n ವ್ಯಾಲ್ಯೂ 1 ಇತ್ತಂದ್ರೆ L ವ್ಯಾಲ್ಯೂ 0 ಇರ್ತೈತಿ. n ವ್ಯಾಲ್ಯೂ 2 ಇತ್ತಂದ್ರೆ L ವ್ಯಾಲ್ಯೂ 0 ಆ್ಯಂಡ್ 1 ಇರ್ತೈತಿ. ಇಫ್ n is 3 ಇತ್ತರ L ವ್ಯಾಲ್ಯೂ 0, 1, 2 ಇರ್ತೈತಿ. ಇಫ್ n is 4 means L ವ್ಯಾಲ್ಯೂ is 0, 1, 2, 3. And then depends upon the value of the L, we are assigning the subcell. L ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಅದು ಯಾವ ಸಬ್ಸೆಲ್ ಅಂತೇಳಿ ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. L 0 ಇತ್ತಂದ್ರೆ S ಸಬ್ಸೆಲ್ ಅಂತೀವಿ. L 1 ಇತ್ತಂದ್ರೆ P ಸಬ್ಸೆಲ್ ಅಂತೀವಿ. L ವ್ಯಾಲ್ಯೂ 2 ಇತ್ತಂದ್ರೆ D subcell ಅಂತೀವಿ. If it is 3, 4, we are using the further F, G like that letters notation we are using. And the angular momentum of an electron is represented by, or it is calculated by the formula L is equal to square root of L into L plus 1. Okay. The angular momentum is equals to L into square root of L into L plus 1 into bracket H upon 2 pi, where L is the Azimuthal quantum number. So, this is the idea regarding the two quantum numbers. One is principal quantum number, another one is Azimuthal quantum number, and this principal quantum number n value we are going to represent here. And in case of the Azimuthal quantum number, depending upon the value of the n, we are assigning the value of the L, and depending upon the value of the L, we are assigning the names of the subcell. So, I hope so it is clear for you people. First one is regarding the definition of the quantum number, that is a set of numbers which gives the complete description or detailing regarding an electron. And then there are mainly 4 types of the quantum number: principal quantum number, Azimuthal quantum number, magnetic quantum number, and then spin quantum number. In that, now we have discussed regarding the principal quantum number and Azimuthal quantum number. So let us discuss regarding the magnetic quantum number. So here the magnetic quantum number represents the energy of the subcell. It represents energy of subcell. Okay, even it gives the orientation of the orbital. It gives idea regarding the orientation of the orbital. It means how the orbital is arranged in the space, that is given by the magnetic quantum number. The magnetic quantum number is represented by the small m. It gives the idea regarding the energy of the subcell, and even it gives idea or details regarding the orientation of the orbitals in the space. And now the value of the m further depends upon the value of the L. So ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಒಂದಕ್ಕೊಂದು ಲಿಂಕ್ ಐತ್ರಿ. ಸೊ n ವ್ಯಾಲ್ಯೂ ಮೇಲೆ L ವ್ಯಾಲ್ಯೂವನ್ನು ಡಿಫೈನ್ ಮಾಡಕತ್ತೀವಿ. ಸೊ n ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರ್ಬೋದು ರೀ, ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿ n ಮೇ ಬಿ 1 2 3 4 ಆ್ಯಂಡ್ ಸೋ ಆನ್. ಹಾಗೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿ L ಏನಾಗಿರ್ಬೋದು ರೀ, ಜೀರೋದಿಂದ ಸ್ಟಾರ್ಟ್ 0 0 1 2 3 ಆ್ಯಂಡ್ ಸೋ ಆನ್ ಅಪ್ ಟು n-1 ವ್ಯಾಲ್ಯೂಸ್ ಇರ್ತಾವು. ಅಂದ್ರೆ n 1 ಇತ್ತಂದ್ರೆ L 0 ಇರ್ತೈತಿ. ಹಂಗೆ ಈ m ವ್ಯಾಲ್ಯೂ ಅಗೇನ್ L ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತೈತಿ. ಫಾರ್ ಎ ಗಿವನ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿ L, ಎಮ್ದು ಎಷ್ಟು, ಈಗ ಎಲ್ದು ಒಂದು ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂ ಐತಿ. ಫಾರ್ ಎ ಗಿವನ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ L, ಫಾರ್ ಎ ಗಿವನ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ L, m ಕ್ಯಾನ್ ಹ್ಯಾವ್ -L 0 plus L values. ಓಕೆ, ಸೊ ಹೆಂಗೆ ಅಂತೇಳಿ ಇವಾಗ ಹೇಳ್ತೀನಿ ನೋಡ್ರಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ m ವ್ಯಾಲ್ಯೂ L ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಡಿಪೆಂಡ್ ಐತಿ. ಸೊ L ವ್ಯಾಲ್ಯೂ ನನಗೆ ಏನೇನು ಅದಾವ ರೀ, L ಈಸ್ ಈಕ್ವಲ್ ಟು 0 ಐತಿ, L ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 1 ಐತಿ, L ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 2 ಐತಿ, L ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 3 ಐತಿ. ಒಂದು 3-4 ಎಕ್ಸಾಂಪಲ್ ನಿಮಗೆ ತೊಗೊಂಡು ಯಾವಾಗ L ವ್ಯಾಲ್ಯೂ 0 ಇರ್ತೈತಿ ಆವಾಗ m ವ್ಯಾಲ್ಯೂ 0 ಇರ್ತೈತಿ. ಓಕೆ, ಯಾವಾಗ L ವ್ಯಾಲ್ಯೂ 1 ಇರ್ತೈತಿ ನೋಡ್ರಿ, ಯಾವಾಗ L ವ್ಯಾಲ್ಯೂ 1 ಇರ್ತೈತಿ m ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ ಅಂದ್ರೆ -1. ಅಲ್ಲಿ ನೋಡ್ರಿ -L 0 ಪ್ಲಸ್ L ಐತಿ, -1 0 ಪ್ಲಸ್ 1 ಇರ್ತೈತಿ. ಸೊ ಯಾವಾಗ L ವ್ಯಾಲ್ಯೂ 2 ಇರ್ತೈತಿ m ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ ರೀ, ಜಸ್ಟ್ ಗೆಸ್ ಮಾಡ್ರಿ, -2 -1 0 ಪ್ಲಸ್ 1 ಪ್ಲಸ್ 2. ಹೌದಾ? ಯಾವಾಗ L 3 ಇರ್ತೈತಿ m ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ -3 -2 -1 0 ಪ್ಲಸ್ 1 ಪ್ಲಸ್ 2 ಪ್ಲಸ್ 3. ನಾ ಹೇಳೋದು ಅರ್ಥ ಆಗತೈತಿ. L 0 ಇದ್ದಾಗ ಎಮ್ನು 0 ಇರ್ತೈತಿ. m ವ್ಯಾಲ್ಯೂ ಯಾವಾಗಲೂ L ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತೈತಿ. ಸೊ ಯಾವುದೇ ಒಂದು Lನ ವ್ಯಾಲ್ಯೂ ಕೊಡತ್ತಂದ್ರೆ ಎಮ್ದ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರ್ತೈತಿ -L2 ಪ್ಲಸ್ L ಇರ್ತೈತಿ. ಸೊ ಹಂಗಂದ್ರೆ L 0 ಇದ್ದಾಗ ಎಮ್ನು ಏನಾಗ್ತೈತಿ ರೀ 0 ಆಗ್ತೈತಿ. L 1 ಇದ್ದಾಗ m ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತೈತಿ -1 0 ಪ್ಲಸ್ 1. L ವ್ಯಾಲ್ಯೂ 2 ಇದ್ದಾಗ m ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ -2 ಹಿಡ್ಕೊಂಡು +2 ಮಟ. L 3 ಇದ್ದಾಗ m ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ ರೀ -3 ದಿಂದ +3. ಓಕೆ, ಸೊ ಹಂಗಂದ್ರೆ ಇಲ್ಲಿ ಇನ್ನೂ ಒಂದು ಪಾಯಿಂಟ್ನ ನಿಮಗೆ ಇವಾಗಲೇ ಹೇಳ್ತೀನಿ. L ವ್ಯಾಲ್ಯೂ 0 ಇತ್ತಂದ್ರೆ ಯಾವ ಆರ್ಬಿಟಲ್ ರೀ ಅದ, ಎಸ್ ಆಗಿರ್ತೈತಿ. ಹೌದೇನಿಲ್ಲ? L ವ್ಯಾಲ್ಯೂ 0 ಇತ್ತಂದ್ರೆ ಇಲ್ಲಿ ಬರ್ತೀನಿ ನೋಡ್ರಿ, ಇಫ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ L ಇಸ್ 0 ವಿಚ್ ಆರ್ಬಿಟಲ್ ಇಟ್ ಈಸ್, ಎಸ್ ಆಗಿರ್ತೈತಿ ಸಬ್ಸೆಲ್. ಹೌದಾ? ಸೊ ಎಸ್ ಸಬ್ಸೆಲ್ ಒಳಗೆ ಏನಾದ್ರೆ ಮತ್ತೆ ಡಿವಿಷನ್ ಐತನ, ಓನ್ಲಿ ಎಸ್ ಆರ್ಬಿಟಲ್ ಅಂತೀವ್ರಿ. ಅರ್ಥ ಆಗತೈತಿ? ಸೊ ಈಗ L 1 ಇತ್ತಂದ್ರೆ ಯಾವ ಆರ್ಬಿಟಲ್ ಇರ್ತೈತಿ, ಯಾವ್ದು ಸಬ್ಸೆಲ್ ಇರ್ತೈತಿ? L 1 ಇತ್ತಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಯಾವ್ದು ಸಬ್ಸೆಲ್ ರೀ, ಪಿ ಸಬ್ಸೆಲ್ ಇರ್ತೈತಿ. ಹೌದಾ? ಪಿ ಒಳಗೆ ಎಷ್ಟು ಡಿವಿಷನ್, PX PY PZ. m ವ್ಯಾಲ್ಯೂ ನೋಡ್ರಿ 3 ಅದಾವು. ಹಂಗಂದ್ರೆ ಇವು ಯಾವ್ಯಾವ, PX PY PZ ಅಂಥೇಳಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಹೇಳತ್ತಿರೋದು ಅರ್ಥ ಆಗತೈತಿ? m ವ್ಯಾಲ್ಯೂ 3 ಏನು ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೈತಿ, ಅದನ್ನು 3 ಸಬ್ ಲೆವೆಲ್ಸ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡೀವಿ. ಹಂಗೆ ನೋಡ್ರಿ L ವ್ಯಾಲ್ಯೂ 2 ಇತ್ತಂದ್ರೆ ಇದು ಯಾವ್ದು ಆರ್ಬಿಟಲ್, ಡಿ ಆಗಿರ್ತೈತಿ. ಡಿ ಒಳಗೆ ಎಷ್ಟು ಸಬ್ ಡಿವಿಷನ್ಸ್ ಬರ್ತಾವೆ, 5 ಬರ್ತಾವ್ರಿ. 1 2 3 4 5. Am I right? ಅರ್ಥ ಆಗತ್ತೈತೆ ನಾ ಹೇಳತ್ತಿರೋದು ಯಾವಪ್ಪ ಡಿ ಎಕ್ಸ್ ವೈ ಡಿ ವೈ ಝೆಡ್ ಆ್ಯಂಡ್ ಸೊ ಆನ್ ಲೈಕ್ ದಟ್ 5 ಏನಾಗಿರ್ತಾವೆ ರೀ ಸಬ್ ಲೆವೆಲ್ಸ್ ಬರ್ತಾವೆ. ಹಂಗೆ ಎಲ್ ವ್ಯಾಲ್ಯೂ 3 ಇತ್ತಂದ್ರೆ ಇದು ಎಫ್ ಆರ್ಬಿಟಲ್ ಆಗಿರ್ತೈತಿ. ಎಫ್ ಒಳಗೆ 7 ಸಬ್ ಡಿವಿಷನ್ಸ್ ಇರ್ತಾವೆ ಹೇಳ್ತೀವಿ. ಜಸ್ಟ್ ನೀವು ಕೌಂಟ್ ಮಾಡಿರಿ ಈ ವ್ಯಾಲ್ಯೂಸೂ 7 ಆಗಿರ್ತಾವೆ. ಸೊ ಹಂಗಂದ್ರೆ ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಒಂದಕ್ಕೊಂದು ಇಂಟರ್ ಕನೆಕ್ಟ್ ಐತಿ. ಅರ್ಥ ಆಗತೈತಿ. ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಮೇಲೆ ಅಜುಮ್ತಾಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಡಿಪೆಂಡ್ ಇರ್ತೈತಿ. ಅಜುಮ್ತಾಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಮೇಲೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಡಿಪೆಂಡ್ ಇರ್ತೈತಿ. ಇಲ್ಲಿ ಎನ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರ್ಬೋದು 1 2 3 4 ಆಗಿರ್ಬೋದು. ಸೊ ಎನ್ ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಎಲ್ ವ್ಯಾಲ್ಯೂ ಎಲ್ಲಿ ಮಟ್ಟ ಹೋಗ್ತಾವ್ರಿ 0ದಿಂದ n-1. ಹಂಗೆ ಎಲ್ ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಎಮ್ ವ್ಯಾಲ್ಯೂ ಎಲ್ಲಿ ಮಟ್ಟ ಹೋಗ್ತಾವ್ರಿ -L to +L ಹೋಗ್ತಾವು. ಸೊ ಈ ರೀತಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಕ್ವಾಂಟಮ್ ನಂಬರನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀವಿ. ಆ್ಯಂಡ್ ದ ಲಾಸ್ಟ್ ಒನ್ ಈಸ್ ಸ್ಪಿನ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್. ದ ಸ್ಪಿನ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ರೀಪ್ರೆಸೆಂಟ್ಸ್ ದ ಸ್ಪಿನ್ ಸ್ಟೇಟ್ ಆಫ್ ಎನ್ ಎಲೆಕ್ಟ್ರಾನ್. Spin state of an electron. So electron is spinning. Electron is spinning about its axis. So it may be spin in the clockwise direction. It may be spin in the clockwise direction, or it may be spin in the anti-clockwise direction. So electron ಯಾವುದೇ ಒಂದು ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ ತನ್ನ ಆಕ್ಸಿಸ್ ಸುತ್ತ ಸ್ಪಿನ್ನಿಂಗ್ ಹಾಕಿರ್ತೈತಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಹೌದಾ? ಹಂಗೆ ಎಲೆಕ್ಟ್ರಾನು ಏನಾಕಿರ್ತೈತಿ ತನ್ನ ಆಕ್ಸಿಸ್ ಸುತ್ತ ಸ್ಪಿನ್ ಮಾಡ್ತಿರ್ತೈತಿ. ಅದು ಕ್ಲಾಕ್ ವೈಸ್ ಆಗಿನೂ ಸ್ಪಿನ್ ಮಾಡ್ಬೋದು, ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಆಗಿನೂ ಸ್ಪಿನ್ ಮಾಡ್ಬೋದು. ಸೊ ಕ್ಲಾಕ್ ವೈಸ್ ಸ್ಪಿನ್ ಮಾಡಿದಾಗ ಈ ಸ್ಪಿನ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರ್ತೈತಿ ಎಸ್ ವ್ಯಾಲ್ಯೂ +12 ಇರ್ತೈತಿ ಕ್ಲಾಕ್ ವೈಸ್ ಇದ್ದಾಗ. ಅದೇ ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಇದ್ದಾಗ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿ ಎಸ್ ವಿಲ್ ಬಿ -12. ಅರ್ಥ ಆಗತೈತಿ ನಾ ಹೇಳತ್ತಿರೋದು. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇ ಬಿ ಸ್ಪಿನ್ ಇನ್ ದ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್, ಆರ್ ಇಟ್ ಮೇ ಬಿ ಸ್ಪಿನ್ ಇನ್ ದ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್. ಇಫ್ ಇಟ್ ಇಸ್ ಸ್ಪಿನ್ನಿಂಗ್ in the clockwise direction, the value of Ts will be +12. If it is spinning along the anti-clockwise direction, the value of Ts is -12. And one more thing, the spinning magnetic momentum is represented by formula S into S + 1 into bracket H upon 2 pi, whereas is again the spin quantum number. So this is how we can explain regarding the quantum number, very important. So ಇಲ್ಲಿ ನೋಡ್ರಿ value of the L 0 ಇತ್ತಂದ್ರೆ M ನು 0 ಆಗಿರ್ತೈತಿ. ಸೊ ಹಂಗಂದ್ರೆ ಎಸ್ ಆರ್ಬಿಟಲ್ L 0 ಇತ್ತಂದ್ರೆ ಯಾವ ಸಬ್ಸೆಲ್ ರೀ ಅದು ಎಸ್ ಸಬ್ಸೆಲ್. ಎಸ್ ಒಳಗೆ ನಾವೇನು ಫರ್ದರ್ ಡಿವೈಡ್ ಮಾಡೋದಿಲ್ಲ. ಹಾಗೆ ಎಲ್ ವ್ಯಾಲ್ಯೂ 1 ಇತ್ತಂದ್ರೆ ಎಮ್ ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ ರೀ -1ದಿಂದ +1 ಮಟ್ಟ ಹೋಗ್ತೈತಿ. -1 0 +1 ಇರ್ತೈತಿ. ಹಂಗಂದ್ರೆ ಯಾವ ಸಬ್ಸೆಲ್ ಆಗ್ತಾವ PX PY PZ ಆಗ್ತಿರ್ತಾವೆ. ಸಿಮಿಲರ್ಲಿ ಎಲ್ ವ್ಯಾಲ್ಯೂ 2 ಇತ್ತಂದ್ರೆ ಎಮ್ ವ್ಯಾಲ್ಯೂ -2ದಿಂದ +2 ಮಟ್ಟ ಅಂದರೆ -2 -1 0 +1 +2. ಸೊ ಅದು ಯಾವ್ದು ಆರ್ಬಿಟಲ್ ರೀ ಡಿ ಆಗಿರ್ತೈತಿ. ಡಿ ಒಳಗೆ 5 ಸಬ್ ಡಿವಿಷನ್ಸ್ ಬರ್ತಾವು. ಓಕೆ. ಸಿಮಿಲರ್ಲಿ ಎಲ್ ವ್ಯಾಲ್ಯೂ 3 ಇತ್ತಂದ್ರೆ ಎಮ್ ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ 7 ವ್ಯಾಲ್ಯೂಸನ್ನು ತಗೋತೈತಿ. ಓಕೆ. ಸೊ ಇಲ್ಲಿ ಇವು ಮೂರೂ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಒಂದರ ಮೇಲೆ ಒಂದು ಡಿಪೆಂಡ್ ಅದಾವ್ರಿ. ಎನ್ ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಎಲ್ ವ್ಯಾಲ್ಯೂ ಡಿಪೆಂಡ್ ಐತಿ, ಎಲ್ ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಎಮ್ ವ್ಯಾಲ್ಯೂ ಡಿಪೆಂಡ್ ಐತಿ. So all these are the 3 quantum numbers are depending upon each other, and in case of the spin quantum number it represents a spin state of an electron. So clockwise direction ಮಾಡ್ತಿರ +12 ಬರ್ತೈತ್ರಿ, ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಒಳಗೆ ಸ್ಪಿನ್ ಆಗತ್ತಿರ -12 ವ್ಯಾಲ್ಯೂ ಬರ್ತೈತಿ. ಸೊ ಕಂಪಲ್ಸರಿ ಒಂದು ಕ್ವಶನ್ ಇದ್ರ ಮೇಲೆ ಇರ್ತೈತಿ. ವಾಟ್ ಆರ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ಸ್, ಡಿಸ್ಕ್ರೈಬ್ ಆರ್ ಗಿವೆನ್ ಬ್ರೀಫ್ ನೋಟ್ ಅಬೌಟ್ ದ ಕ್ವಾಂಟಮ್ ನಂಬರ್. ಸೊ ಡೆಫಿನಿಷನ್ ಬರಿಬೇಕ್ರಿ, ಪ್ರತಿಯೊಂದು ಕ್ವಾಂಟಮ್ ನಂಬರ್ದು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಬರಿಬೇಕು. I hope so it is clear. So if you are not getting anything, you can contact me, or else you can watch the video one more time. You will get all the points. So this topic again I am telling very important concept. Many times if you just look at your examination, annual examination or midterm examination, the question will be asked on the quantum numbers. So this is the important bit of the topic. I hope so it is clear for you. Thank you.